strange sound. Anyway, so welcome everyone to another episode of the Scotland Lightning Talks. These talks, as you already know very well, are an occasion for sharing the great work that our members are doing, to share this work with the broader academic community, the community of experts, professionals, the general public in Scotland and beyond that. Our Scotland network is the Scottish Network on Law and Innovation, is made possible thanks to the support of the Royal Society of Edinburgh. Now, I'm very pleased today to host and learn from Dr. Laurence Diver, who will introduce us to his recent book on Digisprudence. He's actually contributing to a debate on code as law that is very much dear to anyone that is working in the field of law and technology. But without any further ado, I will let the floor now to Dr. Pauline McBride, who will properly introduce our guest and moderate the webinar. Pauline is another proud member of Scotland with a fantastic interdisciplinary and international profile. A PhD in Glasgow, more than 20 years of experience as a Scottish solicitor, and from last year, a postdoctoral researcher in Brussels on the ERC project CoHubical, that stands for Counting as Human Being in the Era of Computational Law, which is led by Professor Mireille Hildebrandt. Pauline, thank you very much for leading this the conversation today, and the screen is yours.
Thank you very much, Rosanna. I'm really delighted to be here with you at the Scotland seminar and as part of the Enlightening talk series. And I'm especially pleased to be able to introduce my colleague, Laurence Diver. Laurence, as he's mentioned, both of us are postdoctoral researchers with the Cubicle project. It's an ERC advanced grant project, and it looks at issues relating to legal tech and computational law. And Laurence's contribution today is very much connected to those kinds of topics. Laurence will deliver his talk and has been made clear we'll have opportunity for questions afterwards. So please do post questions in the chat, and as part of the moderation, I'll be picking up those questions and putting them to Laurence. The best books, I guess, are ones which change your mind and open your eyes to something new. They make you think differently about things that perhaps you suppose were familiar to you. And Laurence's book, Digisprudence, Code as Law Rebooted, is definitely one of those books. If you haven't read the book, I recommend it to you. I know that you're going to enjoy the talk. And without saying more, I'll hand over to Laurence. Laurence.
Thank you, Pauline. That's very lovely introduction. So I'm sharing my screen. Can you see my slide okay? Yeah?
Yes, perfect.
Yes. Great. Okay, thank you for the intro, Pauline, and thank you to Arletta and to Rosanna for all your work in putting this together. As Rosanna said, I'm a postdoc based in Brussels, but in a past life, I was a developer and a designer in a small firm in Edinburgh. And you can probably tell from my accent, I'm from Scotland. I studied at Edinburgh, where the thesis upon which this book is based was written. And so it's really nice to speak to people both in and from the homeland. And as I said to Guido earlier, I hope to return at some point at the end of the current project. So my goals with this talk is to set out the basic ideas of the book, the notion of bridging legal theory and tech practice, to highlight its real world relevance. It's not just an abstract theory, but it deals with a real issue, and I think a fundamental issue. And really to emphasize the need for interaction between law and design practice. So to consider what developers in the real world actually do, not what computer scientists in the university do, but what people who build real applications do. And to be practical about that and realistic about the kinds of tools that they use, how they use them. Now that's a lot to cover. I can't do all of that either in this talk or in the book, but it's a starting point. And I do hope that you find it interesting. But before I begin getting into the book, I kind of want to paint a little bit of a picture, which might draw you in a little. This innocuous and rather old-fashioned looking computer is at the very center of one of the biggest miscarriages of justice in British legal history. It's called a Horizon system, and it was made by Fujitsu at the turn of the century, 1999. Now, in 2000, one of these systems was installed in every post office in the United Kingdom. And the idea was to make post office work more efficient, to use less paper, to centralize the accounting of post office work. And I remember this firsthand. My parents had a post office in the Highlands of Scotland. We had one of these installed in the year 2000. It was very exciting. It had an ISDN link, which at the time was cutting edge. So it was all very exciting. Now, what happened is over time, over the next decade or so, accounting shortfalls were discovered in these systems, in the numbers which were returned back to the central offices. And beyond a certain threshold within the machine, within the code of the machine, fraud was assumed. And so the postmasters and postmistresses who ran the local post offices were locked out of the machine as a result of this technical presumption. And ultimately, they were accused of fraud. And over 1,000 of them were convicted of fraud. Many of them were jailed. Many of them were fined and were forced to pay the shortfalls in the accounting amounts from their own means. This destroyed lots of livelihoods and resulted in some suicides. So pretty grim what happened here. Now, what was the legal background to this? Well, prior to 1999, the Police and Criminal Evidence Act provided that statements from a computer are acceptable only if it is shown that the machine is working properly. Now, the England and Wales Law Commission thought that this was too onerous a standard. They thought that formal verification of software, the mathematical verification of the correctness of a piece of software's execution, that was too unusual, it was uncommon, it was expensive and time-consuming. They also accepted the suggestion made by Professor Colin Tapper in '91 that most computer error is either immediately detectable or results from error in the data entered into the machine. Now, what was the result of all of this? What it meant was that on the basis of the Law Commission's recommendation, Section 69 of PACE was repealed and a common law presumption took effect, to the effect that, in the absence of evidence to the contrary, the courts will presume that mechanical instruments were in order at the material time. Now, the issue here is that that presumption is categorically false. Almost all software contains bugs. Bugs are defects or unintended conditions that the software can get itself into, which were not intended by the designer of the software. And the defect rates in software are surprisingly high. And it's been shown or estimated that even in ordinary software projects, there will be somewhere between 1 and 100 bugs per 1,000 lines of code. These are examples of lines of code. Even in safety critical systems, there's going to be roughly 1 defect per 1,000 lines of code. So that's like planes, medical equipment, and so on. To put that into context, Windows 10, the operating system, which some of you are probably using right now, is estimated to contain between 50 and 60 million lines of code. And that means there's probably somewhere between 55,000 and 5.5 million defects in the operating system. And it certainly feels that way sometimes. Now, obviously, some of those defects are going to be more important than others, have greater effect than others. Some of them may never even be found. They're buried so deeply within the system. The point being, many errors and behaviors, unexpected behaviors, they emerge over time. And it's often not obvious what exactly they are until some very strange or esoteric situation comes to pass, and then the bug presents itself. So some of these bugs are latent. They can take years to find. Now, coming back to the Horizon case, what was the effect of this? The effect of the presumption was that the evidential burden was on the postmasters and postmistresses to prove the presence of the bugs that they thought were in there. But they had no access to the data or to the system or to the code underlying the system. They were essentially locked out, and therefore they couldn't contest that code. So the common law presumption operated, and they were de facto guilty of fraud. So we had the worst possible combination. We had a bad piece of code. It was buggy, and it was constraining in the way that it allowed the postmaster, postmistress to interact with it. And that bad piece of code was protected in turn by a bad piece of positive law, this presumption. All of this was made worse in the end when it finally came to court because the post office led expert witnesses who claimed that the code was robust and error-free. which obviously turned out not to be true. And you've probably seen in the news in the past few months that finally some justice has been done, but not too late for some. So I'll return to Horizon a bit later, but bearing all of that in mind, we can turn now to the central claims of the book, several of which are reflected in the Horizon story. So the theory that I've tried to develop is both descriptive and normative. On the one hand, it's trying to make sense of how code regulates, practically speaking. And then on the other, it's trying to take a theoretical stance on the kinds of standards that are necessary to legitimize that form of regulation. And the basic argument runs like this. Firstly, code creates an alternative set of rules, and it can impose those rules more directly than law can impose its rules, or should even try to impose its rules. This alternative set of rules competes with law and sometimes overrides it. Second, commercial programming environments and practices don't tend to impose limits on themselves, unlike law, which is constrained by constitutional limits. And those constitutional limits impose formal qualities which are independent of, depending on your position on this, independent of the substantive purpose of the rule. Thirdly, I think constitutional limits should be imposed on code rules to ensure that the rules of the code, the design, affords citizens certain fundamental actions which are necessary in a democracy. Fourth, those limits should be grounded in jurisprudence, because there's so much theory on what constitutes a legitimate norm in the field of jurisprudence. And second, they should be framed for implementation in the design sphere. Fifthly, the place to do this is in the development process. So, for example, targeting the tools and practices of developers, integrated development environments, programming languages, development paradigms. Now, I mentioned jurisprudence here. And speaking of jurisprudence, you might wonder about this name, Digisprudence. It's a little bit of a mouthful. For me, jurisprudence means many things. Depending on your jurisdiction, depending on your legal culture, it may mean different things to you too. My emphasis is very much in terms of legal philosophy rather than the reasoning of courts. So we're thinking about big questions like what is and is not a legal system? What requirements should it have? What's the nature of a rule? That kind of thing. That leads us to legisprudence, which takes this philosophical approach and applies it to a specific area of the legal world, namely the making of legal rules in the form of legislation. What makes those rules valid? Not just describing what a legal rule is, but describing the characteristics a legal rule ought to have. So it's a normative thing. And then finally, that takes us to digisprudence. So applying that kind of analysis to digital norms and their design, not legal norms, but digital norms. So what would make a code rule valid, legitimate, and acceptable in a democracy? So the book aims both to describe how code actually imposes rules and how it should impose rules, if at all. So in that sense, digisprudence is to digital rules as legisprudence is to legal rules. Now, the second part of the title is Code is Law. Now, you're probably familiar with this idea, as Rosanna said, from Lessig and others over the past couple of decades. Now, I try to build on Lessig's insights about the ability of code to regulate, much of which I agree with, but I also depart quite significantly from what he says, hence rebooted. I don't accept his equivalence of code, market law, and social norms, firstly. I don't really accept his economic view, which seems to somewhat normalize things in a way which I think is problematic. What I do is take account of design practice, of human-computer interaction, the philosophy of technology, and I think that's where much of the theoretical novelty lies in the work that I've tried to do. Now, ironically, despite the term code is law being the title, I think code is not law, and it's precisely the ways in which code is not law that makes this analysis necessary. In a sense, it's more than law because it can regulate us citizens much more directly than law can. It can constitute our behaviour, and it does that according to a certain logic, often a profit-driven logic. And at the same time, it's also less than law because the way that it does that is potentially illegitimate. It's not been legitimized. It doesn't have certain characteristics, which textual law does have, doesn't allow for interpretation, doesn't allow, at least in principle, for easy contest. So the basic physics of the rules in code are quite different from those in law. And the book is really interested in the interplay between the two. Now, the structure of the book is based around basically three questions, three parts which kind of map onto these three questions. How does code regulate? How should code regulate? And how do we implement that in the end? So, bearing all of that in mind, we can consider part one and the first question. The book considers how code regulates behaviour and uses various theories from philosophy of technology and science and technology studies. Now, I'm not going to go into all of that right now because there's way too much, but I'll try to canvass some of the broad themes. Earlier this year, I was teaching in Tel Aviv, and I came across this bench design on the street there. And ask yourself what you see here. It's kind of a slightly dirty bench, but forget that and just check out the design. It's nice for chatting, it's nice for drinking a coffee, maybe playing some cards with a friend, etc., but can you lie down? No, you can't lie down. What does that mean for, say, homeless people? This is an example of hostile architecture, which I'm sure you're all familiar with. You've probably seen examples in your own cities. What it demonstrates is that artifacts have politics, to use a well-known phrase. The artifacts, they shape our behavior according to certain values, even if that's not intended by the designer, even if it's not obvious to the end user. So you might come to this bench not even thinking about lying down, so it doesn't even occur to you that it's a thing that you can't do with it. That doesn't make it any less impossible for you. So a central concept which is overarching here is the notion of technological normativity, or the idea that, as Hildebrandt puts it, the way a particular technological device constrains human actions, inviting or enforcing, inhibiting or prohibiting types of behavior. So technologies and artifacts, they shape our habits, they shape our ways of acting and our practices, and therefore so too does their design, by definition. So we need to ask ourselves, what actions and behaviors does an artifact enable, constrain, and make possible? Does it invent? Does it bring into the world? Now, these are not natural facts. These are not things about nature that we just find out there. These are creations. So we need to consider how they arose, under what conditions they arose, what the incentives were for that, who was involved, who are the designers, who are the developers, who are the producers, who are the intended end user or classes of end user. What did the designer have in mind when they created this thing? Are those end users in fact enabled in the way that was intended? And what unexpected uses does the design of the artifact make possible? Now, implicit in all of that is a certain kind of contingency about the kinds of relationships which arise between all of those different parties. And this points to the concept of affordance. This is one of the concepts which is quite central to the book. Now, this has its origins in ecological psychology in the 1970s. It's about how organisms, animals originally, but all organisms perceive their environments. So what is the animal capable of in a particular environment at a particular moment? So there's a set of relationships constantly arising between the organism and the place in which it finds itself. This idea was imported into design in the 1980s by Donald Norman. He was particularly interested in interfaces of computers and of other man-made artifacts. Now, to give you an example, to make this a bit more concrete, a very common example in literature is two doors, one with a pad and one with a handle. Now, the one with the pad affords pushing, while the one with the handle affords pulling and potentially also pushing. Now, unless you can grip the edges of this pad, you're not going to be able to pull that door, all things being equal. Now, we need to question then what the assumptions are being made here about both the ability to push and pull and the signaling of those abilities by the designer. What about disabled people? Someone who's in a wheelchair might not be able to reach up and grab this handle, it's too far away. A child might not be able to reach it. What about cultural differences where the pad doesn't have any meaning for a particular culture? The signal is not what a particular culture would recognize as having the meaning that we might expect. And what that hints at, what that implies, is that design is always done with a class of people in mind. A set of assumptions are made, and this fits with the idea of user personas. So we kind of, as designers, we create archetypes about who is going to use the system and for what purpose. And we build according to the archetypes, who we expect to use the system and how. This relates to the next aspect of design that I cover in the book, which is the idea of inscription. So if an affordance is an individual relationship between me and the artifact, what I can do with the artifact, an inscription is like a story almost, like a kind of almost like a film script for how I, as the end user, am intended to, or how the designer intends me to use the artifact. Again, there's going to be particular end users in mind, and there are thousands of these inscriptions around us all the time. So, for example, the idea of double clicking, this did not exist before, let's say, the early 90s, the idea of double clicking on an icon, or the idea of liking. This was a thing brought into the world by Facebook, which is now ubiquitous. It's in pretty much every social media platform. These are now second nature to us, and they will probably be built into, designed into most subsequent similar technologies, at least for the foreseeable future. Now, just as we can write inscriptions which are helpful to us, which do useful, interesting things, we can also write inscriptions for control purposes, to prevent certain uses. And this is sometimes referred to as disaffordance. A very famous example of this is a contested example, but it makes the point, is the bridges designed by Robert Moses on Long Island in New York. As the story goes, he designed these at certain heights so that buses couldn't go under them. And at the time, this was the 1920s, 1930s, mostly African Americans used buses in New York because they didn't have the resources to afford cars. And this, in essence, meant the bridges meant that African Americans couldn't access the beaches. So there was a sense in which the policy, this policy, if in fact it was correct and real, this racist policy was being outsourced to the design of the bridge. And that can be, that outsourcing of policy can be more or less explicit. So in this case, it was quite implicit. But there are other examples where it's much more explicit. Think back actually to the bench. That's quite an implicit policy if we don't want people sleeping here. Here we've got a sleeping policeman. Very much the policy is one of slow down. It's been outsourced to the architecture and built right there in front of you. So in the end, there's this kind of goal of engineering obedience in some way. There's a spectrum of the weight or the directness, but there's the sense of obedience in some way being engineered into the very architecture of our surroundings, and by extension into the architecture of digital artifacts. Now, sometimes this engineering is legitimate, but often it's not. And when it's not, online at least, we often refer to it as dark patterns, particularly in the last few years, also abusive design. So an example, which is not quite abusive, but certainly annoying, that I discovered the other day was on the Trainline website, where the marketing opt-out is beneath the inscription that they want me to follow, which is one of pay now. They want me just to click the big green button because it's big, it's green, captures your attention. They don't want you to be doing this because this is not in their interest. So what they've done is they've followed a legal rule here, but they've not really followed the spirit of the legal rule. So there's a difference, there's a gap there between the spirit of the rule the spirit of the rule and the design reality that's been created. Another egregious example is the Facebook GDPR notice from back in 2018. This large notice, I don't know if you remember, appeared when you first logged into Facebook after the coming into force of the GDPR. And it had these fake notification icons up here. These were actually static images. And these showed up whether or not you actually had any notifications. And of course, the point was to manipulate you into getting through this annoying legal thing so that you could get to your notifications. These red badges, incidentally, are another form of inscription. It's become perfectly embedded now. We're very much used to the idea that if you see an icon with a red badge on it, that's something that you need to click because it's telling you something. There's something waiting for you that you have to go and see. So taken together, all of these different examples and approaches to varying degrees, they demonstrate this idea that code is somehow more than law. It has an impact on our behavior that's much more direct than law can. So that's looking at the issue from a kind of a design perspective, very much in brief. Now I want to flip a little bit to look at it from a legal theory perspective. Now I know it's after lunch, so we don't want to go into this in too much detail, but suffice it to say, one way to think about this is to first ask, where's the problem? Where can we locate the problem? And in this model here, we can see the usual set of legal relationships that we're all familiar with. So we've got the top-down relationship between the Constitution and the state. The state creates norms which affect both the citizen / end user and the product designer. And these are, at least in principle, in a functioning democracy, these are legitimized by the processes and institutions of that democracy. But we've also got this bottom-up approach. On the one hand, it's legal, so we've got contractual norms between the product designer and the end user. We've also got this technological normativity that I've been describing. As we've seen, though, that there's no necessary connection between the technological normativity and any extant legal norm. The code rule may or may not be compliant with any legal rule whatsoever. Therefore, we need some form of procedure or some form of mechanism to contest the technological normativity, the code rule, to check if the rights are violated or if legal effects have been undermined. So a central question is, how do we reflect the rule of law values in code? But before we get to that, I want to go even deeper, one level deeper. This lack of the rule of law in code arises from what I've described as computational legalism in the book. And I'll explain what that is in a second. But first of all, like, why am I talking about legalism when I've explicitly said that code is not law? In what sense is computation legalistic? Well, the way that code shapes behavior and action, I think, reflects or is analogous to a particular way of shaping behavior and action in law, and that way is called legalism. It's this idea, this kind of almost ideological position that is interested primarily in rules. Law is all about rules. It's about predictability of action, very determinate outcomes. It's very much about legal certainty above all else. And that reflects certain values around a particular notion of freedom, stability, capitalistic ideas, and certain strands of conservatism. We can contrast that with legality, which is based on argumentation, based on ongoing procedure, the holding of tensions which are productive, which are healthy, and the publicity of reasoning, which reflects slightly different values, individual dignity and autonomy, responsiveness to conflict, and ultimately legal protection as an umbrella concept. These have overlaps. It's not quite as easy to distinguish them in the way that I have, but just for the sake of setting out the theory here. So code is not legalism per se. Computation is not legalistic per se, but it's analogous with it, I think, in certain respects. And those analogies, that analogy comes up from certain characteristics which code has, which give it, I think, this legalistic nature, metaphorically speaking. And the characteristics are as follows. Firstly, it's rulish. This comes from James Grilman, 2005 article, fabulous term. It's rulish. Code creates a specific web of rules, a specific web of normativity that we are subjected to. But that normativity has hard-edged. Nothing outside of the rule, as it's written inside the machine, will ever run. Only what's inside the rule. The representation of the world within the machine is also very limited by definition. Only what the designer anticipated in advance can be represented there. It can't generate new ideas about the world outside of itself, which is obviously very different from the way that we interpret legal rules. Execution is also mindless, provided that the requirements contained in the code are present. The code will execute no matter what. So it doesn't matter what extenuating circumstances are present, what contextual reasons there might be not to do it this time. The code doesn't know any of that. It will just keep going. And that refers also, or connects also to the idea of immediacy. Code is fast. Computers are fast. There's no gap between the computer encountering the rule and that rule just being executed. Again, that's very different from law, where we might encounter the rule, but we, by definition, as humans dealing in natural language, have to interpret it first. And even then, we still have the opportunity to decide whether we're going to act on it. And this idea of immediacy is very connected with the engineering focus on efficiency and speed, which is core to the ethos of contemporary programming practice. Code is also immutable to a great degree. Now, it can be updated, of course, but until the point it's updated, the code as it exists right now inside the machine is the code that will be executed. So until someone makes the effort to make a change, the code is fixed, and the rule that's written is the rule that will be enforced. There's two forms of opacity, I think. There's the classic black box opacity, where we can't see what's happening underneath the hood. That's important. But another one is a kind of epistemic opacity, where yes, we might be able to read the code. It might be transparent, but do we understand what's actually going on, even if we can see it? These two parts, these are two forms of opacity. Pervasiveness, code is everywhere. It structures everything from the innocuous to the important. I think that's evident. And lastly, private production. It's often made according to profit incentives. And even if it's not, the processes of its production are often hidden, protected by IP law in a certain kind of ironic way, which prevents us accessing the reasoning behind it, which is another way in which it's different from laws, textual laws, where we can see the process of legislating. So this idea of legalism is about you just take the rule and you accept it. As Bankowski says, don't think about it, just follow the rule. And I think code takes this to such an extreme, potentially. So each of these elements of computational legalism, they feed off each other. Any one of them in isolation probably wouldn't be that much of a problem, but they kind of coalesce into an amalgam, which gets accelerated almost and leads to what one might term the internal immorality of code. The internal immorality of code. Now, anyone with a legal theory background who can remember the classes that they would have done is probably seeing the parallel here with Lon Fuller's idea of the internal morality of law. So he came up with 8 principles of legality. I'm not going to go through them, but his goal here was to target some similar ills. So to avoid the rulishness of legal norms, you don't have to just follow the rule. You are given time to think about it, to make sense of it, to decide precisely whether or not it's appropriate, and then to contest. You're treated with dignity. You're allowed an opportunity to respond to the rule. You're not an automaton, you're autonomous. And your understanding of the rule is facilitated, of the body of rules which we're subject to as citizens. But he's by far not the only person to have discussed this, and the book goes into more detail about other people. It does create a nice congruence here. So we've got the internal immorality of code, the internal morality of law. And my goal in the end is to map these in some way. I'm going to do it with affordance theory. The goal being to make computation less legalistic. But first, I'll return very briefly to the post office scandal. The practice here, just to show how it's computationally legalistic, the practice here was very strongly structured by technological normativity. The postmasters and mistresses, they had to use the system. They couldn't opt for anything else. With very strict inscriptions in it, for obvious reasons. So this is not always illegitimate, of course. They needed to ensure that to the extent that it did it, that fraud was not happening, and that et cetera, et cetera. So per se, it's not a bad thing. It's just in this case, we saw the result. It's rulish. There was no latitude for interpreting the rules. The lockout was absolute and immediate. Again, that's immediacy and immutability. Opacity, the system locked them out. They couldn't see any logs. They couldn't get access to the system to even extract evidence in order to counter the presumption or to lead evidence in court in some way. It was privately produced by Fujitsu, who of course had a commercial interest in portraying it as foolproof. And ultimately, all of these things came together to undermine the contestability on the part of the citizens, i.e. the postmasters and postmistresses. So what could have been done about that? This is where we move to part 2 of the book, how code ought to regulate if at all. Now, coming back to computational legalism and Fuller, if we want to create a kind of internal morality of code to counter the internal immorality of computational legalism, what we're trying to do is to avoid legalism in code rules, just as we want to avoid legalism in legal rules. Now, the goal here, importantly, is not compliance, because compliance with rules is important, but it's actually just more legalism. In the end, it's you, as the designer, taking a rule and saying, right, I've complied with the rule, therefore the system is finished, it's done, it's good. What I'm thinking of is something deeper, a kind of legality by design, which is a bigger, deeper concept which lies beneath compliance with specific individual rules. And to do that, we need to translate Fuller's formal requirements, as well as others, into design goals. And this mapping from the book is my attempt to do that. So this is taken from the book, page 164. And what I identify, so before we had a description of affordances as a way of describing how tech regulates. Now I'm using them as a normative resource to say the affordances that should be present, that must be present in order for the code to be legitimate. So these affordances can tackle computational legalism in the spirit of a kind of Fullerian spirit of minimal formal legitimacy. And affordance is quite powerful here because it's quite abstract and it allows for application across many types of system. And of course, there will be different emphases depending on the system in question. There may be some of them which are less relevant than others for a given context, and that will depend. And the goal in the end is to create a kind of inner morality of code to reflect the spirit of the inner morality of law. So the mapping is not exact, it's not perfect. Code is not law. Tech normativity is not the same as legal normativity, but that's absolutely fine. The point is to exhibit the same spirit, to afford equivalent capabilities in order to tackle the same or analogous ills. So there's, very, very briefly, there's 3 types of transparency identified. Many of these things are clustering together ideas that have existed for some time, and I'm perfectly aware of that. 3 types of transparency: provenance, who created the code, where does the liability sit? So software systems often comprise many, many, many parts, and we need to know who did what, where they came from. And this is particularly important with upstream design choices, which is an issue coming to the fore in the distinction between providers and users in the forthcoming AI Act. Transparency of purpose. In law, we get explanatory memoranda, recitals. We can understand the policy goals of a rule, and we can use that in interpreting the rule. So what we need to ask with code is, what's the system intended to do, and to communicate this to the end user. And particularly where there are conflicts of interest, we need to make that clear. So where the purposes are hidden, for example. So a smart meter ostensibly might be for helping you to save money on your energy costs, quite relevant at the moment. But in fact, there might be another interest, which is profiling you for something else. Now, this is not a new idea, but the idea of communicating it properly is extremely important, I think. And that relates then to transparency of operation. This is the usual idea that we get about opening the black box, to understand what's happening as it's happening. And so what we need then, this is where HCI, human-computer interaction, very much comes to the fore. We need interfaces that explain at point of use what's going on, so that the user, the end user, can comprehend what's happening. So we're not talking about terms documents which whitewash bad actors or bad operations, but interfaces which help that, which help, not whitewash, which help to explain things. And again, there's a connection here with the AI Act and the transparency requirement, for example, around chatbots, which are not human. They have to identify themselves as such. This is an example of respecting the end user. Delay. This connects to comprehension. As I said before, computers are fast, almost immediate in many cases. But sometimes we need them to match our speed. And to do that, we need to introduce frictions. We need to introduce delays where that's important for human values to be upheld. Now, legal text is slow. Some might say too slow, but it's slow. And that's often a feature and not necessarily a bug. We can interpret what the text means to us in the context that we're in, and we can decide our response. And that in turn facilitates the rule of law and legal processes. So this idea of consciously introducing delays where they might not actually be necessary into a computational system is somewhat counterintuitive, and particularly since the prevailing ethos in software development is quite the opposite. Choice. We need to give people the power to choose, and that means meaningful choices within the architecture of the system, within its inscriptions, at meaningful points. It also means that the defaults of the system, its configuration that it has when you first use it, must promote the rule of law, it must promote fundamental rights, and not the interests of the designer or the provider, particularly where there's commercial incentive not to do this, which is very often the case. And sometimes that means asking the end user to make a decision, which might be annoying, but in the end, it sensitizes us, it kind of makes us use our muscles, our choice muscles. As Brownsword talks about making moral choices, if we don't do that constantly, we lose the capacity to do it at all. And that's very, very dangerous. And the decision space that the system gives us must be appropriately wide. So 2 bad choices isn't a valid choice at all. It has to give you the right level of opportunity to express your choice. oversight. So there's strong parallels here with Article 14 of the AI Act as it currently stands. The creator of the system must anticipate the need to make future changes. Now, because the code rule is fixed, oversight must therefore be possible, so that if there are adverse, unforeseen impacts in the future, something can be done about it. And that can come in the form of the ability to revoke the code, the commitment to update it, sunsetting the code so it could become inert after a certain period of time, or maybe reducing it to its core functions. So if you have a smart toy, for example, and something goes wrong, you could disable the internet connection part of it, but still a child could still play with it for its core function. And lastly, contestability. This is the umbrella, this is the background this sits above them all. There's two aspects to this, I think. On the one hand, the citizen or the end user needs to be able to observe the problem so that they can decide that there's something wrong that they want to contest. And then on the other hand, the court has to be able to assess evidence of the problem so it can make a legally sound determination. And all of that needs to be anticipated at the design time. So if the system is not designed such that it provides that kind of evidence, then I don't think it's legitimate under this scheme. We can see similar concerns again in the AI Act. So for example, Article 11 requires technical documentation. Article 12 requires record keeping, quite comprehensive record keeping, in fact, which I think is really good. Now, these affordances, they overlap and they interconnect, and in the end, they all kind of contribute to contestability. Because without that, there's no rule of law over technological normativity. And that in the end has to be a crucial backstop in any democracy. It's what these minimum standards, always bearing in mind the possibility of contest, are what could make code as a regulator a legitimate regulator to a very basic minimal degree. And that's important because, like Fuller, this is a kind of formal approach. Minimum standards for good code. The actual purpose, the substantive reason for the system, or the thick, if you want to put it that way, reason for the system is still open. So innovation can still happen. But also, like Fuller argues, constraints on form also impose constraints on substance. So certain applications will, by definition, under this scheme, be illegitimate and therefore unacceptable. So one that doesn't provide contestability or doesn't provide the right kinds of transparency at the right kinds of moments. It's also a minimum standard. So this is not intended to in any way supplant data protection or intellectual property or any other scheme. It's a minimal standard for acceptable regulation of citizens' behaviour. On top of that, all of those other sectoral laws still apply, absolutely. My point is really just to create a kind of floor beyond which you should not go deeper. So all of this is quite abstract, I appreciate. In the book, I apply these ideas to some case studies, some blockchain applications, as I call them, rather than smart contracts, and to the Internet of Things. But I don't have time, unfortunately, to go into that right now. But moving on into the third part of the book, how can we implement these ideas? Now, to make sense of the process, this notion of the programmer, I'm going to briefly canvass here. It's described by Wissman and Krzyzewski in a fabulous paper from 2007. They describe the programmer of the programmer as a person. They think of them as an individual, designing the tools and methods of a coding language, who maintains the ultimate power because he or she, as constructor of the programming language itself, defines what the normal programmer as a user will be able to do. Now, I take a slightly wider view. I don't imagine the programmer or the POP as being an individual. I think it's a context. I think it's a set of tools, languages, and practices. That de facto, a product designer who's building something new is situated within. They're working within a given set of practices, which was there before they started. And those practices, they frame that new work. They frame the kinds of things that will be built and the approaches taken to that building. And so the programmer of the programmer has a normative effect on the product designer. They control, to some degree, what code rules can and cannot be created. And that sounds an awful lot like a constitution. If we come back to this model from earlier, at the top, we've got the constitution constraining the legislator. And now we also have something from the bottom, which is the POP constraining the product designer through the tools, languages, and practices that the POP represents, because it's not one person, it's never one person. And what could happen here is the POP, the tools, the practices, the languages, could encourage or enforce the presence of the digisprudential affordances that I mentioned before. So that whenever a product designer creates something that you or I then use, we know to some degree that we're being protected, or at least those characteristics are present. There's lots of variables there, but let's just in principle. So in the end, we're talking about using design to guide design. Now, what do I mean when I talk about tools, languages, and practices? Well, the first example here is probably the IDE, the Integrated Development Environment. It's like a word processor for software code. I'm sure many of you have used one. It assists you in writing the code, because it's way too complicated to do this just on a, well, maybe some old school people would do it just on a standard Word notepad kind of thing, but these save an awful lot of time. They do an awful lot of, they're sometimes described as a mental prosthetic, helps you outsource some of the thinking to the machine. They provide colored highlighting, indenting, that kind of stuff. They can help you to keep track of a project, which is necessary in anything of any size. And they can even suggest code. So here's an example. And this newer systems even use machine learning to do this. So machine learning trained on popular open source projects. And this is one way in which best practices could actually be encouraged in new software projects by training such a system on best practices in existing projects. A less novel aspect than code completion with ML is just commenting, simple commenting. So including descriptions of what the code does. You can see the gray lines here, that's what they're doing. It's explaining what's happening in the section underneath the comment. Now, an IDE could require these kinds of comments. Indeed, some IDEs automatically generate them, depending on the programming language. And in the end, we could ensure that the code is documented for future readers who can then understand what the system is doing. And that then connects back to some of the AI Act requirements. This idea of understanding the code as a text connects to the next approach, which is looking at programming languages themselves. So different programming languages have different affordances in terms of how intelligible they are for the reader. This is an example of Català, which is a kind of a very new language in the rules as code space, which is gathering huge momentum. It's been developed in France for use in the French taxation system. I work with its author quite closely. And what it does is it puts executable code that the machine can actually run, can execute, right next to the text of the law. The idea being that a lawyer can understand the natural language, the coder can understand the executable code, and not only that, but the design of the language is such that much of the terminology that's used is fairly easy to understand. You don't need a huge amount of training to make sense of this, which is not the case with some other languages, with many other languages. As another example, if we compare these two languages, on the left, this one is, when executed, will display the phrase "Hello World" on the screen. It's quite a common thing to do when you're first setting up a programming environment to ensure that everything is working. You print "Hello World," and then if that works, then at least you've got the basics ready. This piece of code on the right does exactly the same thing. You would never know that though. So the point being that different languages, as I said before, will have very different affordances in terms of how you can make sense of them. And just to underline the fact, I'll show you the names of the two languages there. The one on the left is BASIC. Many of us will have played with that in school. The other one I won't say the name of because I'm being recorded, but you understand the point I'm trying to make. So the broader point is that languages can be designed to be easily understood. And in turn, designers can choose to use languages that are more intelligible in an effort to anticipate the affordance of contestability. So providing that evidence to the court in the end. Now, this relates also to culture. This is a slight tangent, but I think it's very interesting. It relates to culture. Programming languages tend to use English verbs. English is the lingua franca, so to speak, of programming. And that might affect understanding of certain local concepts, might affect the way that they are thought of by programmers as they're building their systems. But alternatives do exist, mostly to highlight this point of the hegemony of English in programming. An example is heart. which I think really underlines this point very beautifully. In fact, what this program does is exactly the same as what this program does, is exactly the same as what this program does, but the intuitive difference is really evident. Okay, not very long, so I'll do 2 more slides and that's me. Another aspect potentially where we can aim some of this work is at development paradigms, so the kinds of project management processes which are followed to create software products. So the old way of doing things, the waterfall approach with discrete steps, tend to be planned in advance, tend to move only forward, or it's very expensive to try to go back. That can be compared with more agile processes, which have become more prominent in the last, say, 20, 25 years. Agile, Scrum, behaviour development, driven development, extreme programming, and the like. These have multiple cycles, and they kind of have discrete chunks of the project which you can test independent of the whole. The idea being that you can move quickly, but you can also have a more robust product in the end because its individual parts have been assessed properly. And that in principle could work for identifying the presence of the affordances that I'm talking about. And this is one of the things, because the cycles go throughout the project, you can begin from the very start to ensure that the affordances are there, that they're implemented from the very early stages. And the lack of implementation at early stages is one of the things that's lamented most in the literature on by design, particularly privacy by design, data protection by design. It's very much about the problem of tacking things on at the end. This is one way to begin to solve that problem. Okay, so that's a very, very brief canvas of some of the ideas that I discussed in the book. There's a lot more in the book. I tried to go into a lot more detail. There's a lot more to do, of course. The theory is very much aspirational. So I'm going to conclude now. The theory is very much aspirational. There's no such thing as perfect legality, either in law or in code, but we can aim for it. Lawyers can engage with coding practice, and in the end, we can use code to help create code. And we can meet programmers on their own terms, on their own turf, as it were. So I want to conclude with 3 takeaways. Firstly, code should embed the rule of law, not just comply with sectoral laws, because compliance is not the same thing as legality. Sectoral law is crucially important, of course, but there's a deeper issue beneath it. And if we can't contest it properly, then we have a problem, I think. Secondly, computational legalism is not inevitable. Programming practice is culturally situated. We can build different ways of doing things. None of this is a given. We can design and use tools which minimize computational legalism, and we can challenge the kind of Silicon Valley assumptions that have framed practices so far at all levels of the development stack, as it were. And lastly, coding practice is a good target for achieving legality by design. Designers are as subject to affordances and disaffordances as we as end users are. So we can use that as a guiding force to produce legitimate code in the end. And I think, coming full circle, what we might then look at is some kind of positive law, some kind of institutional textual law which mandates certain things within the POP level of the model that I showed you earlier. So law could in the end be the thing that saves itself, even when code is the regulator in question. So I will stop there, and thank you very much for your attention. Sorry I've not left very much time. I've had to skip quite a lot of details, but I'll try to cover the main elements, to give you an idea what the book is about. Very interested in your feedback. I see there's lots of chat. I'm very happy to follow up afterwards. I know we need to stop. My Twitter is there, my website's there, I've got the email address. I also just need to say that the book is available open access from the Gruyter. Let's just go to this link here. And it's been made open access through very generous funding by Cubicle, my project, and in turn from the ERC, which I'm extremely grateful for. So I will stop there. Thank you.